Howdy, howdy. The name's Brian Huber, Bryanhuber. If you ever want to see any more videos or any of my older videos, just look it up by the name. I just heard on the news about the tourist submarine that's looking at the Titanic at 14,000 feet. I wish the best. I hope they are recovered and make it back to the surface safely. I was on submarines. I also was on pre-flood submersibles, and then I did go to a commercial dive school. And in 1959, the Trieste, which was a submarine, a submersible, a bath escape made by Picard, he went quite a ways down. And the Navy bought it within a year or two and went all the way to the bottom of the Marianas Trench. His pressure vessel was made of 6 inches of steel that was a 6 foot in diameter. It was very cramped, and but very substantial. He also had a system. This is, we're talking 1959, 1960. He had a system where upon loss of power, a hopper that magnetically holds balls of steel would release the balls. And then once the balls are released upon loss of power, you become positively buoyant. Now there's negatively buoyant, which is a little heavier than water, and positively buoyant, which is lighter. Neutrally buoyant is the same weight as water. So if you're, you lose the steel. Now, what's interesting, this gentleman earlier went up to the stratosphere in a balloon, and he was so far up, and this is quite even before the 1960s, even much earlier. I think it was the grandfather. And they had to have a sealed chamber because it was just so high up, there's no way you can breathe. Anyway, he's using the same idea. Instead of using a gas that's lighter than air, he uses gasoline, which is lighter than water, but like water is not compressible. So if you have a cylinder full of this gasoline that's not compressible, and it makes the overall vessel lighter than the seawater, then it will, upon releasing the metal balls due to loss of power or just because you want to go back up, makes you positively buoyant. It's a great fail-safe system. I know James Cameron made another vessel that was similar, more of a vertical thing, and I'm sure he had some very similar safety designs in this. I don't know how this submarine is designed. I saw some kind of a barge-looking thing. I don't know whether it's a ballast-type barge or what, and if it has an umbilical to the barge. I'm not sure what kind of system he has. I know one thing. I like the idea of overkill. And the Picard from 1959 is overkill. You lose power, boom, you're lighter than water, you go up. You don't have a whole lot of umbilicals or things to get tangled. And I hope these folks haven't gotten tangled. And I don't know whether they have umbilicals. So umbilicals are similar to deep sea divers. These people may or may not have an umbilical to some kind of a ballast barge or whatever. I don't know. But a friend of mine that was a North Sea diver back in the early 70s, who was an ex-Gulf Coast diver, he was at 800 feet, and he was out of his diving bell, and there was bad weather. Something came down on his umbilical, and he had to take his helmet off and go hand over hand, and finally made it. He was teaching folks in the Navy underwater demolition and stuff, and how to navigate underwater. So he did. I always try to find stories from interesting people, whether it's a 90-year-old submariner or a guy that's one of the instructors that's an ex-North Sea diver. But anyway, umbilicals can get trapped and hung up, so I don't know if they have them. But even getting too close with a submersible without an umbilical could get hung up, or possibly the Kevlar or epoxy. I don't know if it's Kevlar epoxy or another type of strands, but anyway, that could, if that pressure vessel gets stuck, it could be a big problem too. Now, if you want to figure they're at 14,000 feet, you got about 7,000 pounds per square inch. It's a little less than half a pound pressure per foot of depth. So that's a lot of pressure, and hopefully if you got different materials, one's Kevlar epoxy and one's made out of something else, they need to hopefully contract and expand under pressure at the same rate. But I kind of like if you're going to go deep, boy, the bath escape is the way to go. Now, back in the 1800s, they went with the bath spheres, the late 1800s, which is a big, thick sphere, and it's got a cable. When you don't have that much cable, that's when you use the gasoline to make it more like a balloon or something, so that you can control your descent without depending on a cable that's really kind of hard to make one long enough. The spool would be almost as big as your ship. So I hope they got good backup systems. I'm sorry, I wish they would have had more of a second vessel. But I know when the Trieste went down, they didn't have a backup vessel, but they had a backup system to make it positively buoyant to get up. But I don't know if the Trieste would have gone underneath things, or you don't want to get too hung up on stuff like that. I'm just hoping they didn't have a leak of the pressure vessel or flooding, and I hope they're alive and that they're able to get back to the surface. But I think it's a tourist type of thing. It's backup systems, backup vessel to rescue it would be good. Whether they have, I'm sure they probably have cable just barely long enough to make that depth hook in. But now the DSRV, I don't think could go that deep, a deep submergence rescue vehicle. That's more designed for mating to overhead hatches on our military submarines. But we'll see what happens. I just think that I'm not sure how the design is set up. I'm hoping it has the kind of backup systems and fail-safe systems that have been proven, since 1960. I pray for it, these folks, and all I can say is we wish you well, and that we hope you get back to the surface. Well, thanks for your time. Bye.